this video, I'm going to show you how we can plot two numeric variables against each other. So how do we plot two numeric variables? Obviously, there are many ways that you can do this, but one way, at least if you don't have too many observations, is that you can make a scatter plot. So how do you do that? So here I'm using a matplotlib, and I'm specifying that I want to make a scatter plot here. And in particular, I specify that I want to have the total bill variable from the tips data on my x-axis. Then I want to have the associated tips on the y-axis. Then here I'm setting the labels, so I have total bill down here, tips up here, and then I'm making it clear that both are expressed in dollar terms. And what I get is the following here. So what you should notice is that I have one dot for each observation. And what we can see is that there is a quite clear positive relationship between these two variables, but there's also some noise in the relation. So this is possible. It's possible to make a scatter plot in this case where we don't have too many observations. I think we have 244 observations or something like that. But if we had too many observations, this plot could easily get a bit cluttered. So it is already a bit down here, right? So, but I think it gives a nice visual representation of the relationship between our two variables. Another issue that could arise is that depending on where you have gotten your data from, you may not be allowed to plot raw observations, because that's in fact what we're doing here. So just keep that in mind. Sometimes it's not possible to make a scatter plot simply because you will not be allowed by whoever provided you with the data. Okay, so what happens if we have too many observations, as I just talked about? So in order to show you this, I'm going to simulate draw 20,000 observations from a standard normal distribution, and then I'm drawing associated targets, y observations, and I specify that I want to have a clear positive relationship between y and x, but there should also be some noise in this relationship. And then I'm creating a data frame out of it. Okay, so here I'm going to display the simulated data set. And what I do is the following. So first, I basically make 4 subplots as a specifier up here. And then in the first plot, I have, let me see, I have 20 observations, and I have 200, 2,000, and 20,000 observations, I think. And what should be clear is that in the first plot, I think this is an okay representation of the relationship between these two variables. But quickly, when we get more observations, it becomes very difficult to see what's really going on here, because all the dots, they're really just on top of each other. So when we have data like this, it seems that the scatter plot is not the best choice of a plot to visualize the relationship between our two variables. So if you really insist that you want to make a scatter plot, then one thing that you can do is that you can change the size of the scatter points. So that's what I'm doing in this plot here. So again, I have the same 4 subplots as I had before, but now I have specified that the more observations that I have, the smaller do I want my scatter points to be, and that's specified with this S argument. Okay, so you can see that now we have a slightly better representation of the relationship between these two variables. We have a slightly better idea of the densities in different parts of this plot. But it's still not ideal, right? So another thing that we can do is also that we can tweak the opacity with this alpha argument. That's what I've done here. So again, I've specified that the more observations that I have, the more opacity do I want. So again, now we have, again, we get a slightly better idea of how many observations that we actually have in different parts of these different areas of our plots. But again, it's not ideal. So what could we do instead? So we can interpolate the data and jointly plot the marginal and joint distributions. So that's something that we can do with the joint plot function Seaborn. So that's what I'm doing here. So here I want to use the joint plot function and plot the total bill against tip as before. I'm specifying that I want to use the tips data, and then I specify that I want to use kernel densities here. I could also have used other arguments, so hex and reg. I'll give you an example in a minute where I'm changing these. But here I'm specifying KDE, and then I'm setting the X labels. And then what I get is the following down here. So I think this is actually a quite nice plot that also works fairly well when we have many observations. So what we have up here and here are basically estimates of the kernel estimates of the marginal distributions, and what we have in here is estimates of the joint distribution of these two variables. So you can see this will also work with when we have many observations, because we are not plotting each observation individually. So here I basically make a similar plot. You can see the code is basically the same, but here I've specified hex instead. So now we have bars instead of a line up here, and then we have these hexagons down here that represent the joint distribution of these two variables. So this is another thing that we can do with this joint plot function. Okay, so as I mentioned, even though it actually becomes quite slow when we have many observations, this approach can be particularly useful when we have moderately large data sets. So in this case, I'm plotting the 20,000 observations from our previous simulated data set, and we can actually see now we've got a pretty good estimate of what our two variables looks like. So first of all, we have the marginal distributions right here. We can see that they are really just normal distributions, and then we also have a very good idea of about our joint distribution of these two variables in here. Okay, so what if we want to see whether there is a clear linear relationship in our plot? That's something that we can do, for instance, with the linear model plot function in Seaborn. So that's what I have here. Again, I specify that I want my x variable to be total bill, tip on my y axis, and then we're using the tips data. And then I'm simply just setting the labels as always. And then what I get is instead a scatter plot similar to before, but then Seaborn also draws a regression line between our data points to make clear what the linear relationship between these two variables, what that is. There is also another plot type that is called a reg plot that does something very similar.